years that most of the people that are now in the flat earth have been looking at this. But we have some very interesting developments that have been going on. For example, let's take a look at this. Now what you see on the screen now is just some of the reasons why we are on a precipice of having all kind of new breakthroughs happen in flat earth. One is we're getting now up to incredible zooms on cameras that are affordable for the public. The new P1000 has increased the zoom even from the P900. And when you take that and combine it with infrared filters, we're able to erase a lot of the distortion and a lot of the haze and atmospheric pollutants that is occurring, maybe even some fog. I haven't actually seen fog tested with it, but in any case, we're seeing much sharper images at much longer distances. You may have seen some of the video where someone has been shooting out of an airplane, seeing like well over 1,000 miles away. But even on the ground, we're seeing incredible footage of people using infrared now filters from extremely long distances, things that would be absolutely impossible on a globe. And this right here is something you're going to be seeing, I predict, a lot more coming very, very soon. In fact, I will be starting to incorporate this once I know they've got the mathematics down. There's still a little bit of fudging to do, so to speak, as far as the diagram on the right. We're going to take a look at these closer. But this is actually a prediction, an accurate prediction using actual science figures to show you, like when you're looking at a distance, like this boat over here, you will be able to see, you know, it looks like so much of it is going over the horizon. We know from zooming in using cameras that these things do not go over the horizon. They come right back into view. But you have this mirroring effect that occurs that we see in a lot of videos over water, the shimmy, inferior mirages, that type of thing. And this formula to the left, it's a lot clearer and a lot easier to use than what this looks like here. My understanding is there's a little teeny bit to work out with the math with these two over here, not a whole lot. But it will tell you, let's say that if this is a, I don't know, so many miles away. I think it says 12 miles. I can't see it real clearly on my screen right now, but whatever this distance is, maybe saying 12 miles, it'll tell you exactly how much will be cut off from the atmospheric mirroring that you will see on a typical day. Actually, it's 10 miles. I see that. It goes by the elevation height, the different angles of looking out, and that is all in these calculations here. Like I said, this is going to be reduced to being much easier than what you see here. In fact, I'm going to, as soon as I make sure that the math is correct, I will be putting this in a calculator myself so that you can say, okay, if I'm looking at 10 miles, how much of the boat will be hidden? Not because of curvature of the earth. We know that's false because you can zoom in. But how much is hidden because of atmospheric mirroring that is normally